question, f from open interval of 0 to infinity. Open interval of 0 to infinity means positive real number set. It is also positive real number set. It is the domain. It is the domain. This one is codomain. Okay. F of x is given as an exponential function. 2 power x, 5 power x. So first, before discussing the nature of the given function, we must know that f of x equal to 2 power x, 5 power x graph means the graph of, we must know that the graph of exponential function. So first, f of x equal to a power x, whereas a is greater than 1. Here two cases are there. One case, first case is a greater than 1. Second case is a lies between 0 to 1, means less than 1 case. Okay, a greater than 1. For example, let us take a is equal to 2, which is greater than 1, means 2 power x. So therefore, this is the y-axis. It will be the x-axis, origin. Okay, here y is equal to, for example, 2 power x, because a is greater than 1 case. Now we are going to draw the graph of a power x when a greater than 1. Put x equal to 0. When x equal to 0, 2 power 0, 1. So y value 1. Let it be, this is 1. Next, x equal to 1, 2 means this is x equal to 1. It will be x equal to 2. It will be x equal to 3. It will be x equal to 4, just like that, and so on. Of course, minus 1, minus 2, and so on, just like that. When x equal to 1, y value 2 means 1 comma 2. What does it mean? It is increasing from 1 to 2, like that. Next, x equal to 2 square, 4. So when x equal to 4 means this is 1, 2, 3, 4. This is the 4. So 2, 4. We are plotting here, right? Now the graph will be like that. This is a power x graph. This is a power x graph. A power x graph. Okay. Next, this is what x dash. X dash means negative x-axis. Negative x-axis means as x tends to minus infinity, then y is equal to 2 power, suppose minus x, 2 power, as x tends to infinity here, minus 1, minus 2, minus infinity. So 2 power minus infinity, that is equal to 1 by 2 power infinity. 1 by 2 power infinity means infinity. 1 by infinity, 0. So therefore, what I am telling that as x tends to minus infinity, y tends to 0, means graph will be for negative side, gradually it is touching the x-axis like that at infinite point. So this is y equal to a power x graph, whereas a greater than 1. It is a increasing graph. Already I said when x equal to 0, when x equal to 1, just by observing 2 points, it is increasing. So therefore, here a power x y, that is equal to f of x, is an increasing function, and increasing function, within bracket a is greater than 1, remember. So by all means, y equal to a power x when a is greater than 1, it is an increasing function. Next, y equal to f of x, that is equal to a power x, second case 0 less than a less than 1. So let us draw the graph x-axis and y-axis, x-axis and y-axis. Just like that, x-axis, y-axis. So for plotting the points, I am taking a value less than 1 means I am taking a equal to 1 by 2, just like that. Then y becomes 1 by 2 whole power x, means that it is 2 power minus x. When x equal to 0, when x equal to 0, 2 power minus 0, 2 power 0, that is equal to 1. So of course this is y value 1. Next x value 1, x value 2, 3, 4 and so on, just like that, and so on, just like that. This is y dash. Next take x equal to 1. X equal to 1, when x equal to 1, then y equal to 2 power minus 1 means 1 by 2, that is equal to 0.5. So at x equal to 0, y value 1, at x equal to 1, then y value 1 by 2. 1 by 2 means this is 0.5. So this one. So at x equal to, it is 1. Look at the board. At x equal to 0, it is 1. At x equal to 1, it is 1 by 2, means 0.5. So gradually it is decreasing. Therefore, the graph will be like that. The graph will be like that. As another point, as x tends to infinity, plus infinity, y will tends to 0. How? 2 power minus infinity equal to, already I said 2 power minus infinity. 1 by 2 power infinity, you come here. 2 power minus infinity, that is equal to 1 by 2 power infinity. 2 power infinity means infinity. 1 by infinity is 0. That's why I wrote y tends to 0. Means y means this graph approaches to x-axis. y0 means x-axis equation. The equation of x-axis is y equal to 0. The equation of y equal to the equation of y-axis is x equal to 0. Equation of x-axis is y equal to 0. Equation of y-axis is x equal to 0. Okay. So it is decreasing. It is decreasing. So the graph will be like that. This is a power x when a greater than 1 case. This is also a power x graph when a less than 1, means lies between 0 to 1. So therefore here y equal to f of x is a decreasing function. Remember, we discuss the nature of the given function with respect to the graphs. This is the shortcut. How? Number 1 minute. Let us draw. You come here. Let us draw any line which is parallel to x-axis, like that. Parallel to x-axis, like that. If this horizontal line meeting at most 1 point, then it is a 1 function. Means what? Horizontal line, if horizontal line intersect the curve at most 1 point, at most means maximum at 1 point, then the function or curve is 1 function, it is at most 1 point. Next, and more than, if it is intersecting more than 1 point, means what? That is at least 1 point, then it is on to function. Remember, if horizontal line is not intersecting the curve, then it is not onto function. It is not onto. Not onto means it is into function. It is into function. 1 minute. Similarly, you come here. Let us draw one horizontal line, means parallel to x-axis. It is intersecting at only 1 point here. Therefore, it is in both cases, in case a greater than 1, in a less than 1 case, f of x equal to a power x for both cases is 1 function. So therefore here 2 power x, once again f of x equal to a power x, in both cases, a greater than 1, a less than 1, in both cases it is 1 function. Why? Because the horizontal line intersecting at only 1 point to the given curve. Here also only 1 point. Therefore here 2 power x, 2 is greater than, base 2 is greater than 1. This is the base 5, it is greater than 1. So therefore in both cases it is 1 function, but not onto function. First option is right. Moreover, we see that here f of x is an increasing function, here decreasing function. So point number 1, if f of x is actually if f of x is either increasing or decreasing, then it is called as monotonic function. Monotonic function means monotonic increasing or monotonic decreasing. So if f of x is an increasing function, then it is called as monotonic function, or if it is a decreasing function, it is called as monotonic decreasing, or simply monotonic, or simply decreasing. Here increasing, decreasing further we can study in calculus. We can study in calculus the vital difference between increasing and strictly increasing, decreasing and strictly decreasing. So for this algebra I am telling that if f of x is strictly increasing or strictly decreasing, then it is called as monotonic function. Of course, if it is only increasing, it is also monotonic. Only decreasing, it is also monotonic. In calculus, we can study that the difference between the two words increasing and strictly increasing, decreasing and strictly decreasing. Later I will explain these two words in algebra also. You look at the board. So if f of x is increasing or decreasing, then it is called monotonic function. Or if f of x is strictly increasing or strictly decreasing, then it is called as a monotonic function. So every monotonic function, next point, every monotonic function, every monotonic function is 1 function. Remember, 1 function. This is the shortcut. That is what increasing, strictly increasing or strictly decreasing. Then it is 1 function. 1 function. In calculus, it is called either increasing or decreasing. Strictly increasing or strictly decreasing, then it is called continuous function. So new word, continuous. Actually it is in calculus. Okay. Continuous means if f of x is strictly increasing or strictly decreasing, then it is called the continuous function. So in algebra, what we are telling, every continuous function, every continuous function is 1 function. So therefore, if f of x is strictly increasing or strictly decreasing or continuous function, then it is called 1 function. This is the 1 function. This is with respect to calculus. In algebra, if the horizontal line intersecting at most 1 point, then it is called 1 function. Otherwise means if it is intersecting more than 1, means at least 1 point, then it is called onto function. Otherwise it is called into function. Otherwise means here, if the curve do not intersecting the horizontal line, then it is called into function. This is some synopsis of 1 and onto function with respect to algebra and with respect to calculus. Later you come here. Increasing means that if suppose x1 comma x2 that belongs to domain of f of x. For example, f of x is 1 function. D suffix f stands for domain of f of x. Suppose let us take 2 points in its domain. So x1 less than or equal to x2, that implies functional values f of x1 less than or equal to f of x2, then f is called as increasing function. Remember, for increasing, the relation less than or equal to, here also less than or equal to, or we can define x1 greater than or equal to x2, that implies f of x1 greater than or equals to f of x2. If this condition is satisfied, then also f is called as increasing function. This is a definition in algebra. Okay, right. Next, for decreasing, for example, you see this one, x1 less than or equal to x2, that implies f of x1 opposite sign greater than or equal to f of x2, then f of x is called as decreasing function. Similarly, if x1 greater than or equal to x2, f of x1 less than or equal to f of x2, here also f of x is called as decreasing function. Next, strictly increasing, strictly decreasing. Strictly increasing means, next you come here, look at the board. x1 less than or equal to x2, that implies means don't take is equal to case. x1 less than x2, that implies f of x1 less than f of x2. So what is the difference between these two statements? Here we are considering equality. Here we are not considering the equality. Or x1 greater than x2, that implies f of x1 is greater than f of x2. What is the difference between these two conditions? Here equality is considered. Here equality did not consider. So this is the difference. So therefore, in such a case, f is said to be strictly increasing if we are not considering equality. Similarly, we can define for strictly decreasing. Strictly decreasing means what? X1 less than X2, that is imply f of X1 opposite sign greater than f of X2 or X1 greater than, is it visible? X1 greater than X2, that implies f of X1 is less than f of X2. In such a case, f is said to be strictly decreasing. This is the definition of increasing function, strictly increasing function, decreasing function, strictly decreasing function with respect to algebra. So finally, ultimately, if f is increasing function, then bluntly say it is one function. If f is strictly increasing, if f is a strictly decreasing function, bluntly say that it is a one function. If f is a continuous function, okay, sir, you can ask me, sir, how can we show that the given function is a continuous function? That is the different topic here. It is in calculus. If limit extends to a, f of x equals to f of a, then it is called as a continuous function at x equal to a. This is the definition of calculus. We are going to study in calculus. Okay, right? Let it be. Next, if f is continuous, then it is one function. So by all means, if f is a monotonic function, then it is one function. Next, the definitions, separate definitions. What is meant by increasing? What is meant by strictly increasing? What is meant by decreasing? What is meant by strictly decreasing? I said here. Okay. So this is the definition of increasing, strictly increasing, decreasing, strictly decreasing. Next, moreover, you come here. With respect to calculus, look at the board. With respect to calculus, if f dash of x is positive, f dash of x means x value, it is in its domain, it is common. It is to be understood. If f dash of x greater than or equal to 0, then it is called increasing function. If f dash of x greater than 0, then it is called as strictly increasing function. Next, if f dash of x less than or equal to 0, then it is called as decreasing function. Next, if f dash of x is less than 0, then f of x is called as strictly decreasing. Next question. If a square plus b square plus c square equal to some constant k, then find the range of ab plus bc plus ca. First option, open interval of minus k by 2 k. Second option, left open minus k by 2 comma k right closed. Next, third option, closed interval of minus k by 2 comma k. Fourth option, right left closed minus k by 2 comma k right open. So we did know a plus b plus c whole square is greater than or equal to 0. Whatever ABC, but whole square, it is whole square, therefore it should be non-negative, means greater than or equal to 0. Another condition, a minus b whole square plus b minus c whole square plus c minus a whole square. It is also greater than or equal to 0. It is non-negative because whole squares are there. Okay, we have two conditions. trivial statements. So from this a plus b plus c whole square means a square plus b square plus c square plus 2ab plus 2bc plus 2ca, it is greater than or equal to 0. Okay, so that implies a square plus b square plus c square equal to k. So instead of that we shall write k plus 2 into 2 common ab plus bc plus ca is greater than or equal to 0. So from this inequation ab plus bc plus ca is greater than or equal to minus k by 2. Let it be statement number 1. Let it be statement number 1. And come here. It is one condition, a minus b whole square plus b minus c whole square, c minus a whole square greater than or equal to 0. So that implies, open the brackets, a square plus b square minus 2ab plus b minus c whole square, b square plus c square minus 2bc plus next one c minus a whole square, c square plus a square minus 2ca. So this sum is greater than or equal to 0. So that implies here, how many a squares are there? A square, 2a square, b square, 2b square, c square, 2c square, and minus 2 common. So 2 into, it can be a square plus b square plus c square minus ab minus bc minus ca. It is greater than or equal to 0. So dividing by 2 throughout the inequation, a square plus b square, a square plus b square plus c square minus ab minus bc minus ca, it is also greater than or equal to 0. So that implies a square plus b square plus c square is given as k. So this is k minus of ab plus bc plus ca is greater than or equal to 0. So that implies k is greater than or equal to ab plus bc plus ca. So that means ab plus bc plus ca is less than or equals to k. Let it be statement number 2. So therefore from 1 and 2 we have ab plus bc plus ca is greater than or equal to, means that it is greater minus k by 2 less than or equal to ab plus bc plus ca, but this value is less than or equal to k. So that implies ab plus bc plus ca is belongs to closed interval of minus k by 2 comma k closed. It is completely closed interval. Okay, this problem is over. Some examples. I wish to deal some examples. For example, For example, if a square plus b square plus c square is equal to 1, then find the range of AB plus, look at the board, AB plus BC plus CA. So here K value is equal to 1. So answer means range closed interval of minus K by 2 comma K. So that is equal to minus 1 by 2 comma 1. Of course it is the shortcut. It is the proof for the shortcut. Hence the problem. Next question. If f of x plus y equal to fx into f of y and f of 5 equal to 32, then f of 7 equal to dash. Here the given condition is f of x plus y is equal to f of x into f of y. So clearly we see that sum is equal to just like product. It is expressed like that. So we can expect the function f of x equal to something a power x. If possible, you can verify f of x plus y is what? According to this, a power x plus y. A power x plus y can be a power x into a power y. So a power x is what? F of x. A power y is what? F of y. So this given condition is satisfied for the function a power x, exponential function. Okay, next f of 5 is equal to f of 5 equal to 32. F of 5 means what? A power 5. A power 5 means instead of x we are writing 5. A power 5 equal to 32. 32 means it is 2 to the power of 5. So clearly when exponents or degrees are same, then basis will be the same if there is equality between the two functions or values. So therefore clearly a is equal to 2. Hence f of x must be a power x, means 2 power x. Now the question is f of 7 is equal to 2 power 7. 2 power 7 is 128. Fourth option is right. Next question. The given condition is f of xy equal to fx plus f of y. F of, given that f of xy equal to f of x plus f of y, means here product is expressed as the sum. Just like let us remember logarithm of m into n formula. Logarithm of m equal to log m plus log n. So it seems to be like that. That's why we are taking f of x equal to log function log x. We don't know about the base. So given value is f of 2, but f of 2 that is equals to 1. F of 2 means what? Log 2 to the base a, that is equal to 1. So that implies 2 is equal to a to the power of 1, because since if a power x is equal to m, that y implies x is equal to log m to the base a according to definition. So that implies therefore a value that is equal to 2. Hence f of x is equal to log x to the base 2. Next, what is the question? F of x log x base 2. So third option is right. Next question, f of x is satisfying the condition f of x plus y plus f of x minus y equal to 2 into f of x into f of y. So f of x plus y plus f of x minus y, that is equal to 2 into f of x into f of y. Whenever it is given as x plus y, x minus y, do this procedure or follow this procedure. First one, put y equal to x. Then it will become y equal to x, x plus x to x. F of 2x plus y equal to x means it is 0. X minus x, that is equal to 2 into f of x into f of y equal to x, f of x. Okay, next, and put y equal to minus x. Second case, minus x means y equal to minus x, x minus x 0, so it is 0, f of 0. Y equal to minus x, x minus again minus x, minus minus plus, x plus x to x, so it is f of 2x. That's why in one side we are getting the same functions or same values if it is in the form of x plus y and x minus y. That's why we put one in first case y equal to x, in second case y is equal to minus x. So what will be the RHS part? 2 into f of x into f of y is minus x in the second case. So therefore LHS part same. Therefore definitely RHS will be the same. So therefore f of x into f of x, that is equal to 2 into f of x into f of minus x. So f of x get cancelled. Actually in the given question they should be given as f of x should not be equal to 0 for all x belongs to capital R. Please add this condition. Otherwise we cannot perform the cancellation law like that. Why? Because if 0 into x equal to 0 into y, don't cancel like that. Don't do this, don't perform this kind of operation. That's why f of x should not be equal to 0. So we are adding the additional condition for this question. Okay, so 2 cancel, then it remains f of x is equal to f of minus x. Of course it is a definition for even function. So here, therefore here f of x is an even function. So f of x minus f of minus x equal to 0 for all x belongs to capital R. So we are putting x equal to 10 for the given question. Put x equal to 10. Put x equal to 10. Therefore f of 10 minus f of minus 10 equal to 0. So right answer is first option.